And so you should let me know when the little light is off, because there'll be a very nice video with no talking whatsoever on it. So it should be a green light. If it's a red light like this, I just have to unmute it again. All right. Factor theorem. How many people have heard of the factor theorem? This is where you feel good, right? How many people have forgotten the factor theorem? Yeah, okay. The factor theorem is based on the same idea as factoring with binomials. The key thing is the last term. So the last term here being a 10. What we're going to look at here is say, if we could factor this into three things, whatever these last numbers are, when it gets FOILed or multiplied out and multiplied out again, these last numbers are going to have to multiply to get 10. So one possibility could be 1, 2, and 5. Does that make 10 when I multiply those together? Yes. Another possibility could be 1, 1, and 10. Maybe you had, yeah, that's about it, eh? 1, 1, and 10, 1, 2, and 5, and different combinations. It needs to be a negative 10, so we don't know if it's, when I have 1, 2, and 5, they could be all negative, because that would make a negative 10. Or I could have two of them positive and one of them negative. I can't have all three of them positive. So the factor theorem says, well, if you could factor this, and it looks something like this, and if we think about our first term here being 3x, the only possibilities here are 3x, x, and x, somewhere along that lines. Now what I did there, if that is right, that is by pure chance, and we're super lucky, but it's most likely not right. But the idea is if we made this equal to 0, well, we know that either minus 5 could work, minus 2 could work. Maybe if the 1 was in a different place, maybe 1 could work, or minus 1 could work. So the first thing that we look at for the factor theorem says if something is a factor, then when you plug it in, it should make it equal to 0. The only possible factors that we're going to look at are ones that multiply to 10. So we're going to look at possible factors. We're going to ignore the 3. It does affect it, but we're going to look at possible factors of plus or minus 1, plus or minus 2, and plus or minus 5. We're going to say those might be possible solutions, and then the factors could be x plus 1 or x minus 1, x plus 2 or x minus 2, x plus 5, x minus 5. Oh, and we also have to include 10, because it could be plus or minus 10. Now what we're going to check is we're going to do some mental math. Chances are if you're going to do mental math, especially with something like x cubed, you're not going to want to start with the 5 or the 10. You're going to want to start with the 1 and the negative 1. So if I plug in 1 into this whole thing, can you see that I would get 3 plus 4 is 7, minus 9, negative 2, minus 10, negative 12. It's not equal to 0. So we now know that x minus 1 is not a factor. Worst case scenario, we'd go through all those numbers and none of them work to find out you can't factor this. Best case scenario, you try either on your first or second try and you get one that does work. So f of negative 1, when we plug that in, well, this would be negative 3 plus 4 plus 9 minus 10. Oh, how does that work? Excellent. That tells us that x plus 1 is a factor. So once you know that x plus 1 is a factor, the best strategy is to use synthetic division. And I'll remind you how synthetic division works. You write the coefficients of all the terms in your function. And if you say that x plus 1 is a factor, then outside here, you'd put negative 1. Bring down the first number. Negative 1 times 3 is negative 3. Then add 4 plus negative 3 is 1. Negative 1 times 1 is negative 1. Add them, negative 10. Negative 1 times negative 10 is positive 10. Add them and get 0. You know that it's worked if you get a 0 there because that last number would represent the remainder. What we got as an answer tells us, and I'm going to write it out the long way, that our original equation, which was 3x cubed plus 4x squared minus 9x minus 10. The shorter way would be to write f of x, so you don't have to write all of those things. But I want to see all of this. X plus 1 was the factor that we pulled out. And what we were left with after synthetic division was a 3x squared from that 3 plus x from the 1 minus 10. And once we've factored it once, the second one is just a matter of factoring something that you factored before. Has to be 3x and x for the first ones. To get 10, you could get that with 2 and 5. 2 would be positive, 5 would be negative, and when I multiply that out, it does work to 3x squared plus x minus 10. Don't feel bad if that factoring takes you a lot longer. I have factored for the last 15 years, almost non-stop, all the time. So it will take you a little bit longer, but I have been factoring like crazy. One of the things that is sort of a gap, I think, between what you get in university and what you get in high school is once you get to university, in some courses, they'll expect that you recognize and know special cubic functions like difference of cubes and sum of cubes, but it's not really in any of the high school curriculum that you get to. So sometimes courses like this are nice because you can say, okay, here are some special factoring ones that are formulas that are nice to memorize. The way that I always memorize them, difference of cubes and sum of cubes. The x cubed minus y cubed, I remember, has a factor of x minus y. And then from that, you can figure out the rest by just multiplying it through. If I have to get an x cubed, I know that I need an x squared to start with for this x to times that x squared to get an x cubed. For my last term to be a minus y cubed, I know that I need a plus y squared at the end for that to work out. Then you have to think, well, what would I need in here, so things that cancel out? I know that when I multiply my x by a y squared, I'll get an xy squared. So what would I need to cancel that out? And then you can figure out that middle term will be plus xy. Some of you might just want to memorize it all together. Same thing with x cubed plus y cubed. You can factor out an x plus y. And then it's exactly the same, except there'd be a minus xy in the middle. So here's an example. The x cubed minus 8. You have to recognize that 8 is a perfect cube because it's 2 times 2 times 2. The x is a perfect cube because it's x times x times x. So you'll get x minus 2. You'll get an x squared here, a plus 4 on the outside. So this would be the way that I would look at it. And then to figure out what would need to be on the inside, well, I know that when I multiply this one times this one, I'm going to get a plus 4x. So in order to cancel that out, I would need to have a plus 2x so that when this hits that, it'll cancel it out. Can you see that strategy that I just used to figure out what would be left? Okay. Now, just so that we can see everything here, I'm going to use some different colors. I'm going to actually multiply this out so you really can see. I'm going to get an x cubed plus 2x squared plus 4x. And then this minus 2 will get multiplied by everything here. I'll do that in black. Minus 2x squared minus 4x minus 8. And you can see that this 2x squared cancels out with that minus 2x squared. This 4x cancels out with that minus 4x. And we do get the x cubed minus 8 that we wanted to start with. But as far as figuring things out, I started with my first term here, and then my last term there, and then just figured out what would I also get and what would I need in the middle so that that cancels out. And then if you'd like to multiply it out to check to make sure it works, you can. But this will work for difference of cubes and sum of cubes. So here we recognize this is perfect cube, this is perfect cube. It's going to be a plus 3b squared, because b squared times b squared times b squared will give you b to the 6. For this part, what do I need here? I'll need an a squared. For the last one, I'm going to need a 9b to the 4. And when I multiply the a by that 9b to the 4, I'll get 9ab to the 4. So what would I need to cancel that out? Well, I'd need a negative. I would need a 3, because that will give me a negative 9. I'll need an a. No, the a's already, no, I'll need an a. And I'll need a b squared. Of course, you could just memorize the formula and then say, in this case, my x is a, my y is 3b squared. And the formula says that x cubed plus y cubed is this. Now, if my x is a, then I would get a. And if my y here, this is a cubed plus 3b squared cubed. So my y would be 3b squared. Then I would have plus 3b squared. X squared would be a squared minus a times a 3b squared plus 3b squared all squared. And you can see when you square 3b squared, you'll get your 9b to the 4. And when I multiply a negative a times 3b squared, that's the same as a negative 3ab squared. So you can have the formula to work from to figure out the factoring. Or if the multiplication works for you, you can do that as well.